with the use of the existing transducer. So what kind of materials we can create or expect to use?
For right now, it's just aluminum oxide because we only have TMA. But if you have hafnium oxide or TDMAZ, or you can do titanium oxide,
Using the same.
different chemistry. You know, you'd have to
But still the same procedure.
no,
Change, we need to change it.
yes, because you're changing the chemistry.
That target. I mean, as we change target for a spike.
Yeah, but here you're using two different chemicals, two different components to achieve one result.
I understand.
This is you're just taking the same material and moving it. So this is a chemical process, that's a physical process.
That's my question. So, if the changing recipe as a result of this chemical process, using the same procedure, we can get different output materials.
If you're using
But
TMA,
it's chemical process.
yes, but you can only get aluminum oxide from TMA. You can't get anything else. So if you want something different, you have to put a different chemistry in it. So there's, like if for some reason your process will require titanium oxide, you would have to either put TD mat on 3B or swap that amp to allow. So you would have to add, you could still use the water
Yes.
for your oxygen component, but you would have to change or add a precursor. The process itself will run very similar.
Now, my question is that you need to have a good understanding and deep insight about the chemical process in order to get your desirable result for that deposited material. Am I right? To develop a recipe which actually works.
You'll have to know what your components are to get what you want. The process itself will be very similar. The process of running hafnium oxide, zirconium oxide, titanium oxide is all the same as aluminum oxide. Visually looking at the process, you're not going to see that much difference. What is going to be different is your end film. So you have to know what you want. It's not, you can't get zirconium oxide with TMA. You just can't get it. So you have to put something, it's called TDMAZ for zirconium oxide. And then you have the TDMAZ with the H2O, that'll give you a zirconium oxide film. So you have to know what you're mixing together.
That's my point. That's my point. Also, the temperature, pressure. I mean, you need to have an insight on the chemical process.
You should have an idea, but that's also another thing with, well, you would use us as a resource. Because there's probably a good chance that we already have something or have, if we don't already have a recipe that we know will work, or we'll tell you it simply can't work on this and why can't it work, we might be able to give you a benchmark for where to start. And we always start on a conservative level and then work up from there. So I wouldn't shoulder that whole burden of understanding what has to be done with the chemical process and what you're choosing, because almost always it's somebody that sees something in a white paper or technical paper that somebody else has already done or experimenting and say, well, can we do this on this system? That's usually how that question starts. And then we say, well, yeah, if you want to do that, then you would need to order this and this and this. We'll go ahead and set up a recipe. If the heating needs to be addressed, we'll address that. And then, okay, go ahead, run some samples, give us some information on what the characteristics of the film are doing. We'll tweak the process in, we'll fine tune it, and then, okay, this is a good point for this recipe to be able to run whatever you want. That'll give you your better chance of success.
So I said, in general, current setup will work for most of the metal oxide. Right, oxide.
Yeah,
Okay.
in general speaking,
Yeah.
yeah.
What about ceramic? Ceramic. Is that one?
Yep. Because you don't need RF sputter for that.
So the current setup doesn't work for ceramic.
Probably not. Not that I'm aware of. That would be a Bruce question.
Okay, so that's something requires upgrade, or just
It-
better off using that?
Okay, for ceramic maybe it should be plasma based, not heating based.
All the ceramic I've ever done, I've done with RF sputter. Because in most cases, you're putting a barrier. Whenever you're doing ceramics, you're doing, some sort of barrier. Most of the time it's done with that. I don't know all the capabilities and limitations are of the ALD process. I refer those questions to Bruce and Art. And it changes all the time. It changes as far as what's new and available. It doesn't change a whole lot on what is already in existence. So, in the recipe, so this is the only process recipe you have for the aluminum oxide. And I have some information I'll give you here in a little bit. But a lot of this stuff you can go on YouTube. And if you do a YouTube of aluminum oxide ALD, then there's a nice little PowerPoint demonstration that lasts about 3 minutes.
Yeah.
And then there's no gray area. It's like, I get it. And also with some other materials. There's a lot of documentation at different universities throughout the world have already had procedures that they put on. Depending on what their tool is, what works on an Oxford ALD system may not work here. Or it may need to be tweaked or changed. That's another scenario where you would say, well, we got this, I seen this paper from Duke where they're running this material on an Oxford ALD system. Could that material be run on the Lesker ALD system? It's going to be yes, but the parameters might be a little bit different because it's a different piece of equipment. This is better than an Oxford system, but it's also a little bit more money too. The recipe for the AB recipe, meaning EMA H2O pairs, is similar as far as lines of the PC pump and PC vent recipe, but what is different is the sub-recipes. So the first step here, it just changes your scan, it sets your scan interval at 1 second. That's just the computer speed for the line. Then it automatically runs the sub-recipe. The sub-recipe, you can click on the recipe, it just does a check, make sure we're not running another recipe. Since I was in a sub-recipe, I can come back to the master recipe. Then it sets an abort recipe. What do I want the system to do if things don't go as planned? That's just abort process recipe. Then it runs a sub-recipe for the gas flow, which we've run a few times now. This sets your gas flow for your process chamber and your source gases. There's a dwell step. This is, step 5 is another sub-recipe. This is what populates the matrix as far as what we've seen in the process. So that'll put all this up here.
The process parameter.
Yes. in
Call it that
this-
experimental design which he has.
yeah, as far as this matrix, it just populates itself.
So which one is that?
This is the sub-recipe here. This, right. Define
That's
is,
it, process parameter. Yeah.
yeah. Then it sets the process
So
phase.
is there any, there is no edit option, right? What do you do like? When you define a process parameter, what do you mean? I mean, when you define it?
You're telling, okay,
You are telling the
TMA
machine-
H2O,
Yeah,
you're putting the process parameters in here.
here,
So if you're running different chemistry, that's not gonna be the same.
right?
You know, the step will look the same, but instead of TMA H2O, maybe you're doing TDMAT and H2O.
So that will be done on the screen previously, right? You did that on the position screen. You change the name. If you have two precursors.
That would change it on this screen.
Yes. So
Yeah.
automatically change will come here also on the recipe editor. Yeah. The name also will change.
Sure,
Right?
right.
Which really what I mean. So now.
You're gonna load a different recipe. That recipe will have to be.
Yeah. So we have. Yes.
Yeah, this
Now we
goes by
have.
the recipe.
Yeah. TMA plus
So
H2O.
you have a new recipe.
So if you have a new recipe, automatically the name will be changed here.
Well, you would create a new recipe. The new recipe would look almost identical to this,
Different name.
but this step right here would be different.
Yeah.
This,
Yeah.
the wording of this step would be different, and then whenever you open a recipe,
That will be different.
this will get different. So if you were running TD mat versus TMA, you'd have TD mat here. You would have a different sub-recipe, and the process recipe would have a different name.
So, a question on the recipe. So
That's
when you
what
talk
question.
about you have different recipes, do you mean you already have something pre-configured like this? You will send to us, we just load? Or it's something we kind of configure, create a new?
What would be best is for us just to load the recipe,
Uh-huh.
and then you see the difference.
Okay.
That would be-
something like this, but you load into the system. We can just, from the drop down button, we can choose which one to.
Yeah, exactly. So where this is back here, if you wanted a new recipe, we would add that recipe in there,
Right?
and then you'll have a different line. You might have a couple different sub-recipes with it.
Who can add that?
We can.
Here?
Anybody can do
or
it.
remote?
We could do it remote.
So you have to be coordinated.
No,
We need to add this.
you have to have the, what's that?
It could be
viewer?
through TeamViewer.
The no access.
Yeah, and then as you see different recipes and the changes of different recipes, you would be able to do things yourself if you chose to. That system, I would recommend, yeah, if you want to change something, change it. Actually, what I would do is I would take an existing recipe, copy it, and then change that. This way, if something gets boogered up, you can still go back to something that works. This system, I wouldn't do that until you get a lot more experience.
Yeah, that's why I asked you how many inputs you need to developing a recipe here means really
Yeah.
We would just put you another recipe.
Yeah.
And then eventually you'll see, oh, okay, whenever I have another recipe, 90% of it's the same, but maybe only, 10% of it changes.
Yeah, well,
So, oh, okay, all the recipes follow a similar format, but this is just changing. Then it becomes clear. But there really isn't a whole lot to compare that to.
Are you aware of like IPO on this current configuration? Indian Ping Dioxide?
I don't know if IQ is done on AOD. It may.
Okay. How about AZO? Aluminum?
I don't know. I'm not sure. Zinc, I think.
Aluminum?
Some of those present problems. Indium, I wouldn't do indium on here. Even if it could be done, I wouldn't do indium on here. I'd do indium in there. That stuff's like,
Yeah, no, they can, yeah, but I think I saw people doing, and it may not be in this system, so I just want to know.
Maybe. Indian, I would definitely stay away from Indian systems. The stuff like depositing bubble gum, it sticks to everything. It's real soft, it's horrible to clean up. For that reason, I wouldn't do it in the ALD system. You could do it in that system and then foil everything up. Because it creeps, it's really weird. It's not, Indian, especially if you're doing like Indian monks and stuff like that, it's best to protect everything as much as possible, but with foil and tape, because it'll creep into little small places. For like if you have a crystal shutter that has an actuator, it'll eventually work its way into the actuator, the mechanical mechanism, and then it'll start dragging.
Wow.
Indian's weird stuff. But stepping back to this process recipe, so it loads up the matrix here with defined parameters. Then it sets the process phase. This is where it zeroes the counter. The current thread, this just changes the speed. The interval, when we see interval, it changes the speed. Sets process active. And then it sets this recipe, which is the time part of it, the precision time part of the ALD, what makes it go so fast. And then it runs the recipe and it just loops back. It goes through AB, then it checks the counter. If not, it goes back and loops, and it goes back and loops. Then once it's greater than or equal to, so it incrementally increase the count. Once they're equal, then it says, okay, finish up. So it turns off the process active, stops ALD, changes your scan interval, so you don't need